This lecture is on solving rational equations, which is found on section 7.7, but let me follow my labeling. It would be 7i. Okay, so this is under solving rational equations, and this one, if you refer to your book, is 7.7. Okay, so let me write down the procedure, and then we will use the procedure to solve the problems. Okay, so let's try that. Let's write down the procedure. Okay, first thing you need to do is to factor each denominator separately to determine the LCD. Okay, so that's what you want to do first, and then the method that we are promoting is to clear the fractions by multiplying both sides. Okay, both sides of the equation by the LCD. So really you're doing multiplying each and every term on both sides, okay, of the equation. So you have to do it to every single term that's on both sides of the equation, and you want to do it by the LCD. And then after that, you're gonna solve the resulting equation. And before you happily box your answer, the last part, which is very important, don't forget, let me put a few stars to remind you, you need to check answers for validity. Okay, and what we mean by validity is really to make sure the denominator does not become 0. That's really what you're trying to check for. So let's run through some examples and to make sure you understand what I wrote here. Okay, so let's try the first example. Say you're asked to solve, okay, and it's x plus 14 over x minus 2 equals 7x over x minus 2 plus 1. So this is a rational equation, okay, because there's an equal sign right here. So when it's an equation, you can consider using this method because there is both sides, okay? So when there's both sides, you're allowed to multiply. That's what equations do. You can add both sides, subtract both sides, multiply and divide, so long as what you do to one side, you do to the other. So in equations, there is both sides, and so you're free to do what you want. In this case, we're going to multiply by the LCD. And if you look at all four of them, the LCD is x minus 2. So I'm going to multiply the first one by x minus 2, second one by x minus 2, third one by x minus 2, and the last one by x minus 2. So that's what I'm trying to do, okay? So now if you look at the first one, which is x, there is nothing to cancel because the x minus 2 is really x minus 2 over 1. So if you think, you can think like this, okay, x minus 2 over 1. So there's nothing I can cancel here, but what I can do is I can multiply. So when I distribute the x into both of them, it's going to be x squared minus 2x. Now in the second fraction, you notice the x minus 2 cancels, leaving me with 14. And in the third one, the first fraction on the right side, the x minus 2 cancels, leaving me with 7x. And the 1, there's nothing I can cancel, but I can distribute. So 1 times x is x, and 1 times minus 2 is minus 2. Okay? So what happens is it kind of clears all the fractions, which is why the name is, okay, clear the fractions. And now you have to solve this equation. Okay, so what I have on the left side is x squared minus 2x plus 14. Not much I can do there. But on the right side, I can combine like terms to make it 8x minus 2. Now, if you look closely, this equation has a term that has an exponent. So this is what you call a non-linear equation. Okay, so when it's non-linear, then you must have 0 on one side. Okay, so 0 has to be there. So that forces me to subtract 8x from both sides and add 2 from both sides so that this entire piece cancels to make it 0. And now everybody's clustered on the left, making it x squared minus 10x plus 16. Okay, so now I'm looking at a trinomial, and that's when I have to think of factoring. So I'm looking at a sum of negative 10 and a product of positive 16. So I'm looking at 8 and 2, and I need negative to be on both. So it's going to be x minus 8 and x minus 2 equals 0. So put each piece to 0, tells me x is 8, and x minus 2 is 0, tells me x is 2. So before you happily say that 8 and 2 are both okay, that's when you have to check. Okay, so you have to make sure the numbers you found does not make the denominator 0. So you notice for that reason, x equals 2 has to be rejected. Okay, because this one makes denominator equal 0. Okay, so what that means is when the denominator is 0, it makes it undefined. Let me see, denominator. Okay, so when your denominator is 0, it makes your fraction undefined, so that's why it's rejected. So the only answer in this question is x equals 8, and that's it. Okay, x equals 2 has to be rejected. Okay, let's try another example. Let's call this example 2. So solve, and what you have is x plus 4 equals 6 over x minus 1. So this is a example, right, where it's a rational equation again, and because it's both sides, I'm allowed to multiply everybody, and the LCD in this case is the denominator x minus 1. So I'm going to multiply by x minus 1, x minus 1, x minus 1. So for the first one, there's nothing I can cancel. I'm going to distribute, so I have x squared minus x. In the second one, I'm also distributing, so it's going to be 4x minus 4. In the last side, the fraction on the right, it cancels the denominator, so I only end up with 6. So what I have is x squared plus 3x minus 4 equals 6. Okay, so again, this is nonlinear. So if it's nonlinear, then you must have 0 on one side, which forces me to subtract 6 on both sides, leaving me with x squared plus 3x minus 10 to be on the left side. Now I'm looking at the trinomial, so I'm thinking of sum and product. Sum is positive 3, product is negative 10. So which two numbers will do the trick? Positive 5 and negative 2. So it's x plus 5, x minus 2 equals 0. So when I put x plus 5 to 0, it tells me x is minus 5. And when I put x minus 2 to 0, it tells me x is 2. Now, in this scenario, if you look, both negative 5 and 2 does not make the denominator 0. Okay, so this is where both are okay. So your final answer is going to be negative 5 and 2. Two answers this time. Okay, let's look at another example. Let's say example 3. Okay, so you're supposed to solve, x over x plus 2 plus 2 over x minus 1 equals 6 over x squared plus x minus 2. Okay, let's try that. So the first fraction I can't factor the denominator. I'm trying to factor the denominator to decide who is the LCD. So this is the only trinomial here, and if you factor it, it actually becomes x plus 2 and x minus 1. So if you look at all three fractions, okay, all three, it tells me that the LCD is going to be x plus 2 and x minus 1. So I'm multiplying this by x plus 2, x minus 1. Same here, x plus 2, x minus 1. Same here, x plus 2, x minus 1. Okay, so you notice that the first one, the x plus 2 cancels, so what I end up with is x squared minus x. In the second fraction, x minus 1 cancels. Watch out, you have to distribute the 2. Okay, so it's going to be 2x plus 4. So 2 times x, 2 times 2, like that. Okay, in the last fraction, x plus 2 and x minus 1 cancels, leaving me with 6. So again, it is nonlinear, okay, and I know it's nonlinear because of the exponent. So what I have on the left side is x squared plus x plus 4, and that's equals 6. So I'm going to subtract 6 on both sides, leaving me with x squared plus x minus 2. Now if I factor this, it's going to be x and x, 2 and 1, and it's going to be plus and minus, which tells me I have two answers. X is minus 2 and x is 1. Now when I put minus 2 into the first fraction, for example, minus 2 plus 2 makes it 0. So that tells me I have to reject. And when I put 1, it's okay for the first fraction, but it's not okay for the second one, because 1 minus 1 makes it 0. So I reject again. So I have two answers and both are rejected. So in that sense, I will have to say it's no solution. So you must check your answers to make sure that they are acceptable. So let's get you to try some, and these are found on page 340 of your textbook. And this is numbers 25, 29, 39, 41, and 45.